All right, let's go ahead and talk a little bit about our new unit. Our new unit is about polynomial functions as well as power functions. And later on, we're going to also talk about rational functions. So from your notes from last night, hopefully you saw that we're talking about polynomial functions. Something that's important for you to note from your notes from yesterday is this definition here. So it tells you a polynomial looks like this. I know there's a lot of variables in there, but this a sub n minus 1, a sub 1, a 0 are all supposed to represent integers. That's what it says underneath here. So make sure you're aware those are all numbers, and then the rest of them are just the single variable x. Underneath here, it talks about, here are some examples determining if something is a polynomial or not. And that's something I want you to be able to do. So the first example says it is a polynomial of degree 4 because the highest exponent number is 4. The next one, they say it is not a function, mostly because if you notice, the square root of x is the same thing as x to the 1/2. And you're not allowed to have a fractional power. That's what they say here. It has to be a non-negative integer. So that's why that one's a problem. Part C is also a problem because we have this thing in the denominator. Anytime you have this thing in the denominator, it's going to make it so you have like an x to the negative something. That is also not a function. So these ones are not functions here. Polynomial functions, excuse me. These two over here, D and D, are functions, polynomial functions, because they can be written in terms of x. So like part D can be written as f of x equals and then 0 times x to the 0. If you recall, that is 1. Part E can also be written as g of x equals and then 8 times x to the 0. Sorry, that's a times. Since x to the 0 is 1. So that it is something that can be written in that format from above. Part F, they talk about, do you see if this is a polynomial or not? So you don't have any fractional or negative exponents. X can't be in the denominator, so that one actually is a polynomial. The rest of it talks about multiplicity, which I'm hoping you talked about last year. So x to the second times x minus 2. Multiplicity talks about how often a factor occurs. So this factor of x, if you really wrote it out, would be written twice. So it occurs twice. And this x minus 2 only occurs once. So the multiplicity of x minus 2 is 1, and the multiplicity of the x is 2. We'll talk about how that changes your graph. In here, it kind of talks about, what happens. It says it touches versus it crosses. This whole spiel is really quite important. We're going to talk about that. Sometimes I use the term bounces instead of touches, just so that you are aware that it's meaning the same thing. So if it has an even multiplicity, then it bounces off at that x-intercept. And if it has an odd multiplicity, then it crosses through at that value. Last term to know is turning points. These turning points are basically same-ish as maxes and mins. So those are called turning points because they're changing from increasing to decreasing and vice versa. So sometimes we'll use that term to kind of talk about both maxes and mins. One of the rules they talk about in this is that turning points, the maximum number of turning points that you have for any polynomial has to be one less than the degree. It's written down here under this theorem. So if f is a polynomial function of degree n, then f has at most n minus 1 turning points. So if you didn't write that one down, make sure it's written somewhere. So in summary, max number of turning points, n minus 1 for a polynomial of degree n. If you have an even multiplicity, it should bounce. And if you have an odd multiplicity, it should cross. And then last but not least, talking about what makes a polynomial or not. I'm going to write it more explicitly up here, just in case you don't have it written down. To make something a polynomial, you can't have any fractional or negative exponents. So say no fraction, no negative exponents. If you have that, then it's not a polynomial. It's not what we're going to be studying for the first half of this chapter. Also note that x cannot be in the denominator. Cannot be in the denominator. And that's the same idea as a negative exponent, but it's not obvious. Sometimes people don't realize that that's what it actually means.